Welcome to week 4 of Fundamentals Python and Machine Learning. In this lesson, we are covering the chapter 4 data visualization using matplotlib from Python Machine Learning by Wei-Meng Lee. In the previous chapter, we learned how to use pandas to work with tabular data. We create data frames, select the columns, filter rows, inspect data, and prepare features and labels. Now we're going to take the next step. Instead of only looking at rows and columns, we will learn how to represent data visually. Data visualization helps us to see patterns, trends, relationships, and outliers that might not be obvious from the table alone. This is important because before we build machine learning models, we need to understand the data. This chapter focuses on several important visualization topics. First, we will discuss what matplotlib is and why it is useful. Then we'll look at line charts, which are often used to show trends over time. Next, we will study bar charts, which are useful for comparing categories. After that, we will cover pie charts, which shows parts of a whole. Then we will look at scatter plots, which help us explore relationship between two numerical variables. Finally, we will introduce Seaborn, a visualization library that works well with pandas and can make statistical charts easier to create. The goal is not to use to create a chart, the goal is to learn how to use charts to understand data. A dataset may contain hundreds of thousands of rows. When we look at a large table, it can be difficult to understand what is happening. For example, imagine we have student attendance data for several weeks. A table may show the numbers, but a chart can quickly reveal whether attendance is increasing, decreasing, or staying stable. Visualization helps us answer questions such as, are there trends over time? Which category is the largest? Are two variables related? Are there unusual values or outliers? Does the data look balanced or imbalanced? In machine learning, that question matter. If the data has a problem, the model might learn wrong patterns. Visualization helps us find those problems earlier. Visualization is usually a part of exploratory data analysis, often called EDA. EDA happens before model training. A typical workflow may look like this. First, we load the data. Second, we inspect the data using pandas. Third, we visualize the data. Fourth, we clean and prepare the data. Fifth, we train and evaluate a machine learning model. Visualization helps us make better decisions before modeling. For example, if a scatter plot shows a strong relationship between two variables, that may help us choose features for a model. If a bar chart shows that one class is much more common than another one, that might warn us about the imbalance in our dataset. So visualization is not just a decoration, it is part of understanding the data. Matplotlib is one of the most widely used Python libraries for creating charts and graphs. It allows to create many types of visualizations, including line charts, bar charts, pie charts, scatter plots, histograms, and more. In many Python examples, matplotlib is imported like this. Import matplotlib.pyplot as plt. The part called pyplot provides functions that make it easier to create charts. The alias plt is the standard convention. So when you see plt, you should recognize that it refers to matplotlib's plotting tools. For example, we may use plot, bar, pie, scatter, and show from plt. Each of these commands help us create different types of charts. Most matplotlib charts follow a basic structure. First, we import the library. Second, we prepare the data. We choose the type of the chart. We add the titles and axis labels. Finally, we display the chart, as you can see on the example there. The code creates a simple line chart. The title helps us viewer understand the purpose of the chart. The X label describes the horizontal axis. Y label describes the vertical axis. A chart without labels may be confusing, so titles and labels are important. The first chart type is the chapter in the line chart. Line chart is commonly used to show change over time. For example, we can use a line chart to show attendance across weeks, sales across months, temperature across days, or website visit over time. The x-axis usually represents times or sequence. The y-axis represents the value being measured. A line chart is useful when the order of the data matters. For example, if we are looking at attendance from week 1 to week 4, we care about how the value changes from one week to the next. The line helps us see that trend. Here's a simple line chart example. This chart shows attendance values over 5 weeks. If the line moves downward, attendance might be decreasing. If the line moves upward, attendance might be improving. If the line jumps up and down, the data may be inconsistent. In machine learning course, this type of visualization helps us understand whenever a feature changes over time. It can also help us ask better questions before building a model. A basic chart is useful when we can often make it easier to read. For example, we can add markers to show each data point. We can also add a title and axis label, which should almost always be included. Good charts should answer three questions. What is it measured? What do the axes represent? And what should be the viewer notice? When creating charts for assignments or reports, do not only generate the chart, explain what the chart means. A chart without interpretation is incomplete. The next chart type is the bar chart. A bar chart is useful for comparing categories. For example, we can compare average scores by student, sales by product, tickets by department, or counts by category. In a bar chart, one axis usually contains categories, and the other axis contains numerical values. Bar charts are useful when we want to see which category is larger, smaller, higher, or lower. For example, if we compare average score for several students, the tallest bar shows the highest average. Unlike a line chart, a bar chart does not usually focus on continuous change over time. It focuses on comparison. Here's a simple bar chart example. This chart compares assignment average for 4 students. Each student has one bar. The height of the bar represents the assignment average. From the chart, we can quickly see which student has the highest average and which student has the lowest average. This is the easiest way to scan a table manually. Bar charts are usually useful when summarizing categories. Use a bar chart when you want to compare categories. Good examples include average score by student, number of students by final result, number of support tickets by category, sales by product, attendance by course section. Bar charts works really well when the categories are separated from each other. However, if the data shows a trend over time, a line chart might be better. Choosing the right charts matters. The chart should match the question you are trying to answer. The next chart type is the pie chart. Pie chart shows patterns, parts of a whole. For example, we can see a pie chart to show percentage of students who passed and failed. Each slide represents one category. The full pie represents 100% of the data. Pie charts are useful when we have a small number of categories and we want to show proportions. For example, pass versus fail. Another one will be completed versus not completed. Yes versus no survey responses. However, pie charts can become hard to read when there are too many categories. If there are many categories, a bar chart is usually better. Here is a simple pie chart example. This chart shows many students passes and fail. The labels identify each slide and the auto-PCT option displays percentage on the chart. In this example, the viewer can quickly understand the distribution of final results. This can also be useful in machine learning. For example, if 95% of the data is one class and only 5% is another class, we might have a class imbalance problem. Visualization helps us notice that issue. Pie charts can be useful, but they should be used carefully. They work best when there are only a few categories. If there are too many slices, the chart becomes difficult to read. Pie charts are also not the best choice when we are values closer together, because it might be hard to compare slices size accurately. For many comparisons, a bar chart is clearer. A good rule is this: use a pie chart when you want to show a simple part to whole relationship. Use a bar chart when you want to compare categories more precisely. The next chart type is a scatterplot. A scatterplot shows the relationship between two numerical variables. Each point of the chart represents one record. For example, we may plot attendance percentage on the x-axis and quiz average on the y-axis. Each point should represent one student. The scatter plots are especially important in data analysis and machine learning because they use help us use relationships. For example, we might ask, do students with higher attendance also tend to have higher quiz average? If there's a positive relationship, if there's no clear relationship, are there outliers? The scatter plots are one of the best ways to visualize and inspect relationships between numerical features. Here's a simple scatter plot example. In this chart, each point represents one student. The x-axis shows attendance, the y-axis shows quiz average. If the point generally move upward from the left to right, that might suggest a positive relationship. This means higher attendance might be associated with higher quiz average. However, we should be careful. A scatter plot can show a relationship, but it does not prove that one variable causes the other. Visualization helps us explore, but we still need analysis and judgment. Scatter plots are also useful for finding outliers. An outlier is an value that is very different from the rest of the data. For example, if most students have attendance between 70 and 100%, but one student has 20% attendance, that point might stand out. Outliers are important because they can affect analysis and machine learning models. Sometimes an outlier is real, an important value. Other times, it might be a data entry mistake. Before removing or changing an outlier, we should understand why it exists. Visualization helps us notice these unusual values so we can investigate them. Matplotlib works well with pandas. Often the data we want to chart is sorted in a data frame. For example, we suppose we have a data frame called df with the columns named attendance and quiz average. We can create a scatter plot using these columns. This is a common pattern. Pandas help us organize the data. Matplotlib helps us visualize the data. Together, they help us understand the dataset before modeling. The final major topic in this chapter is Seaborn. Seaborn is another Python visualization library. It's built on top of matplotlib and is designed to make statistical visualizations easier and more attractive. Seaborn works especially well with Pandas DataFrames. It is commonly imported like this: import Seaborn as sns. The alias sns is the standard convention. Seaborn can create many types of plots, including scatter plots, bar plots, count plots, box plots, and heat maps. In this chapter, the important idea is that Seaborn gives us a higher level way to create usable charts with less code. Here's a simple Seaborn example. This creates a scatter plot using columns from data frames. One advantage of Seaborn is that we can refer to columns by name. It makes the code easier to read when working with tabular data. We can also add categories using colors. The hue options colors points based on a category, such as pass or fail. This can help us see whatever groups behave differently in the data. One of the most important skills in visualization is choosing the right chart. Use line chart when you want to show a change over time or sequence. Use a bar chart when you want to compare categories. A pie chart when you want to show simple parts of a whole. A scatter plot when you want to explore relationship between two numerical variables. Use Seaborn when you want to create statistical charts more easily, especially when working with Pandas data frames. The chart should always match the question. Before creating a chart, ask yourself, what I'm trying to show? I am comparing categories. I'm showing change over time. Am I showing proportions? Am I exploring relationships? The answer will help you choose the correct chart. Before we finish, let's review some common mistakes we can have with data visualization. The first mistake is forgetting titles and access labels. A chart should clearly explain what the viewer is seeing. The second mistake is using the wrong chart type. For example, using a pie chart with too many categories can make the chart hard to read. The third mistake is putting too much information into one chart. A chart should simplify the data, not make it confusing. The fourth mistake is ignoring outliers. Outliers might reveal problems or important exceptions in the data. The fifth mistake is creating a chart without explaining what it means. In this course, do not only submit a chart, explain the pattern, trend, or relationship that the chart shows. Charts are powerful, but they must be interpreted responsibly. A chart can show a pattern, but it does not always explain why the pattern exists. For example, if the scatter plot shows that students with higher attendance also tend to have higher quiz average, we should not immediately assume that attendance is the only cause. Other factors might also matter, such as study habits, previous knowledge, work schedule, access to technology, or outside responsibilities. This is important in machine learning because models can also find patterns. But not every pattern should be used without carefully thinking. Good data analysis requires both technical skills and responsible interpretation. Let's summarize what we covered in Chapter 4. Matplotlib is a Python library used to create charts and graphs. Line charts are useful for showing trends over time and sequence. Bar charts are useful for comparing categories. Pie charts are useful for showing simple patterns of a whole. Scatterplots are useful for exploring relationship between two numerical variables. Seaborn is a visualization library built on top of Matplotlib and works very well with Pandas DataFrames. Most importantly, visualization helps us understand data before machine learning. It helps us find patterns, compare values, identify outliers, and prepare for better analysis. For this week, your goal is to practice creating and interpreting visualizations. You should be able to create a line chart, bar chart, pie chart, and scatter plot using Matplotlib. You should also be able to explain when each chart type is useful. As you complete the assignment, do not focus only on the code. Ask yourself, what question does this chart answer? What pattern do I see? Are there outliers? Is this the best chart for type for the data? How could this visualization help before building a machine learning model? In the next chapter, we will move into scikit-learn, and we're beginning working more directly with machine learning models. Pandas help us organize data. Matplotlib help us understand the data visually. Scikit-learn will help us train the model using that data.